Hi everyone. Today we are going to do the first chapter of class 12. If you'll see the first part of class 12, that is electromagnetism. So electromagnetism basically divided into two parts. One is electrostatics and another one is electrodynamics. So electrostatics, if you'll see, as far of concern like electrostatics, that is going to be charges it is at rest. And then electromagnetism, if you will see, that is electrodynamics. If you will see, that is charge. Dynamics means what? Obviously motion. So charge is in motion. So electrostatics, if you will see, two chapters are there. First two chapters of class 12, that is what? uh, Electric field and charges. And second thing is what? Electrostatics, electrostatic potential and capacitance. If you'll see the electrodynamics, then we can say current, electricity. Then magnetism means two chapters are there, so those two chapters, EMI, AC. So like this it is divided. If you'll see, the whole topic name is what? Electromagnetism. So we will see electro first. What is electro means? Obviously anyone can say electro means what? Everywhere if you will see, that is about charge. Electrostatics, electrodynamics, electromagnetism. So electro terms comes regular, right? It is regular here. So we should know what is electro means, and properly we should investigate like what is that, what is the properties of that. Those things we are going to see first. Fine. So now we can say electro means what? Charge. Let's see what is charge now. So let's see, if you want to see like you guys that how it is there. So electrodynamics, if you will see, electromagnetism, if you will see, electrostatics, electric field and charges, you guys can write by this way. So the first chapter of class 12, we can say electric field and charges. So two parts are there, electric field and charges, right? Electric field and charges. Fine. So here if you will see, one part is electric field and another part is what? Charges. So of course we'll have to know both the things about electric field as well as charges. So first we'll learn properly about charge, because the whole class 12th is completely dependent upon charge. Fine. So charge, if you'll see, charge is what? Is an intrinsic property, like what? Mass. As mass, what is mass? No one knows, right? Mass, something is there, so that is what mass is. This is an intrinsic property. Likewise, charge is also an intrinsic property. Fine. Now unit of charge, symbol of charge, if you'll see, that is coulomb. Obviously that I wrote there. And then unit of charge, if you'll see, that is what? Coulomb. Of course charge is a scalar quantity, right? Charge is what? Scalar quantity. Or we can say charge, if you want to define properly, we can say one more thing is, charge is a basic property of a material. By virtue of it experiences electric field as well as magnetic field. What is charge? Charge is a basic property of a material. By virtue of it experiences electric field as well as magnetic field. Fine. So it is an intrinsic property also. Now we are supposed to see what is charge and what is mass, that we are going to see. So mass, if you will see, charge, let's see charge first. Charge, if you will see, it can be positive and negative, like types of charges. But mass cannot be negative, right? So mass cannot be what? Negative. Fine. Charge does not depend upon speed, but mass depends. Charge does not depend upon mass, but mass depends on that. So does not depend upon speed, depends upon what? Speed. Fine. So what is that? M is equal to m naught. You might have seen this formula in class 11. Fine. There are two types of charges basically, if you'll see. One is positive charge and one is negative charge. Let's see what is positive charge and what is a negative charge. Positive charge, if you guys will see, let's see, whenever we are defining any element, electronic configuration, like suppose let's take a sodium element. If you will take, so we know 281, 2 electron here, 8 electron here, 1 electron here. So whenever we are discussing about any atom electronic configuration, or you want to transfer, you want to give electron, you want to give some charge to an atom, or you want to take out from that atom, then we always deal with electrons. If you will take out proton, if you will give proton, what will happen? The atom will become destroy. So it is better we'll only take what? The electron. Fine. So now we can say we can take out electron and we can give also what? Electron. One more thing is what from here we can learn that whenever we are going to talk about any charge, any atom, then we are going to talk about what? Electron. Let's say how much, minimum how much electron we can give inside the atom. 1.5? Impossible. Like it seems the name by the word 1.5, no, it can't be, right? That is what it comes. So means what? Minimum charge we can give is what? 1. Minimum charge we can take out is what? 1. So whenever we will deal with charge, that always will be what? 1, 1, 1 with the multiple of 1, right? It can be negative, it can be positive, but somebody will say 1.5, impossible. Fine. So it's like you went in the market and then you ask me that give me a half potato, which is not possible. Give me a half tomato, which is not possible. Say likewise, here is electron we cannot divide it, like half electron we cannot take it. Fine. So that is not our concern. Now we are supposed to learn is what? So whenever we are talking about any atom to give something or to take out something, then we are only talking about with respect to what? Electron. So we are supposed to define also positive charge or negative charge with respect to what? Electron, not with respect to proton or neutron. Fine. So charges, if you will see, charge is a basic charge we have learned. Excess of electron is what? Positive charge. Sorry, excess of electron is negative charge. Deficiency of electron is what? Positive charge. So we can write here the definition that excess of electron is positive charge. Excess of electron is negative charge. And deficiency of electron is what? Positive charge. I just mistake, but that's fine. So that is what about charge. Basic unit of charge. One is unit of charge is coulomb, but basic unit of charge is electron. Remember that, because we cannot divide the charge. So one star point you can write, and then you can write here is basic unit of charge. Charges is what? Electron. One electron value is what? 1.6 into 10 to the power of minus 19 coulomb. Fine. So now we learned what is charge, types of charge, and basic unit of charge. Let's see now we are going to deal with what? Properties of charges. So properties of charges, if you will see, then we can say what? Many like few properties are there that we are going to discuss here. The first property we are going to discuss is, obviously, like charges repel each other, unlike charges attract each other. Means positive repel, negative repel, positive attract, negative positive what? Attract. So the first property we are going to do is what? Like charges repel each other. So let's write that properties of charges. Properties of charges. So like charges repel each other, unlike charges attract each other. Next property what we are going to see is conservation of charge. Conservation of charge, if you will see, charge is neither created nor be destroyed. It can be transformed from one form to another form. What is conservation of charge? Same like conservation of energy, conservation of momentum, same here also. So charge is neither created nor be destroyed. It can be transformed from one form to another form. That is what? Conservation of charge. Example, if you will see, uranium 92 238. So that will break down 90, 234, and then what? Helium 2 and 4. Best example to understand what? Conservation of charge. See, 92, 92, 238, 238. So that is what? Conservation of charge. So conservation of charge, we can say that what? Charge is neither created nor be destroyed. It can be transformed from one form to another form. That is what? Conservation of charge. Fine. Now conservation of charge, if you'll see, let's take an example. Suppose for an isolated system, charge is going to be constant. For an isolated system, charge is constant. 3 coulomb minus 1 coulomb plus 2 coulomb, 4 coulomb minus 2 coulomb, and what is x here? So here if you will see 5 minus 1, so 3 coulomb, 2 coulomb minus 1 coulomb, so that is going to be 4 coulomb. Here is what? 4 and 2 minus 2 plus 2, 4 minus 2 plus x, that is going to be equal to what? 4 coulomb. 4 cancel out, so x is equal to what? 2 coulomb of charge. So charges are conservative in nature. So by this way we can say charges are conservative in nature. Fine. Next, if you will see quantization of charge. Quantization of charge. So quantization of charge, if you guys are going to see, then we can say what? Quanta means packet. As we learned that minimum charge is going to be 1. So same here also, quantization of charge, if you are saying, then let's see, directly we'll jump in the formula that Q is equal to NE. N is what here? N is integer. Of course it is a number, but it should be integer. As we learned before, the basic unit of charge is electron. It means what? It cannot be fraction. All electron, suppose somebody will write 3.5 electron. No, not possible at all, right? No. Plus 2 minus 2 electron. Yes, it is possible. So that is quantization of charge. Charge will always be integral multiple. Charge will always be an integral multiple with the basic unit of charge. Charge will be always an integral multiple with the basic unit of charge. The basic unit of charge is what? Electron. Yes. Let's see one numerical. So quantization of charge is what? Charge is always will be charge is always an integral multiple. Charge is always an integral multiple with the basic unit of charge. So that is what? Q is equal to NE. Let's see a numerical is what? Find the number of charges in one. Find the number of charges in 1 coulomb of charge. Find the number of charges in 1 coulomb of charges. So 1 coulomb of charges, if you will see, Q is equal to what? NE. We know, we want to find N. This is 1 coulomb. NE. E is what? 1.6 into 10 to the power of minus 19. So if you will take this here, so 1 by 1.6 into 10 to the power of minus 19, that can go up. 10 into 10 to the power of 19 by 16 is equal to N. Let's take 1 0 here. 100 by 16 into 10 to the power of 18 is equal to N. Then it is going to be how much? 6.25. So 6.25 into 10 to the power of 18 is equal to N. That is the number of charges present in 1 coulomb of charge. Fine. So you guys understood what is quantization of charge. We understood conservation of charge. We understood quantization of charge. Charge follow algebra rule. Alright, that charge follows algebra rule. What is the meaning of that? 3 coulomb plus 2 coulomb minus 1 coulomb. It is going to be 4 coulomb. That is what charge follow algebra rule. So this is all about charge. We learned about what is charge, what are the properties of charge, what is the types of charges. So these things we cover in this lecture. Next class we'll see about Coulomb's law, numericals based on that. Fine.